I'm Yingjun Wu and founder of RisingWave Labs. So for RisingWave, it's more focused on stream processing, data streaming, stream processing, streaming management. But interestingly, I will talk about the Iceberg, right? I actually will tell you about why I want to talk about Iceberg instead of stream processing today. So before starting the company, I was at Redshift, and then I spent some time in IBM research. And so if you know Redshift, you know that's why it's basically a data warehouse system, and it's designed for batch, right? It's probably very similar to Snowflake and probably BigQuery. But I feel that's okay. Definitely, 4 years ago before I started the company, I feel that's okay. Redshift is so good at doing batch processing. Snowflake is also coming up, right? And it's also super good at doing the batch processing. Why not? But how about streaming processing, right? Because in today's world, a large percent of the data in Redshift, probably 30% of the data actually came from the Kafka, came from the Kinesis, right? This data is streaming data, and why can we just use some streaming processing system to handle the data, right? So that's why I studied RisingWave. RisingWave is a distributed SQL streaming database, right? And we call it a best-in-class stream processing, management, and analytics. And it's open source project and under Apache 2.0 license, which is super friendly to everyone. And I know that's what we, in some companies, will say that, okay, look, well, we only accept open source product. And we also have some regulations regarding the license, right? In our case, it's Apache, right? And you can just download it and install it on your laptop or probably Dockers. So we have already been building a product for over 4 years, actually 4.5 years. And we have already been adopted by definitely more than 2,000 companies, from startups to Fortune 500 companies. I actually have some slide deck with a logo showing up our paying customers, but because for the meeting, actually the talk is recorded, so yeah, due to some regulations, right, I could not do that. But so we have already entered some of the world's largest companies, and also entered some critical companies. The most exciting paying customer we have is actually the space station company, which is super, super cool. And which is way cooler than any other companies, any other technology companies like banks is sending the space station to the sky, right? It's super cool. But you know, RisingWave is like a stream processing system, and most of the customers came from the financial services, banks, right? Banks, trading firms, brokerages, and exchanges, right? Crypto, right? Crypto companies. But why I talk about Iceberg, right? Is it just because Iceberg is hot today? Yes, Iceberg is definitely hot. But we actually started exploring Iceberg actually 2 years ago. It's not this year. It's not 2025. It was actually at 2023. And we started exploring Iceberg actually just because of a coincidence. So before 2024, the architecture looks like this. Well, I mean, the diagram looks like this. Well, basically, RisingWave consumed data from the Kafka, from Postgres CDC, from their data warehouse, right? And then do processing, and then because it's a database system, and we can power we can have the data stored in RisingWave in order to power different online services or the notebooks or whatever, right? But in many cases, we find that our users actually really love to send the data into Snowflake, into BigQuery, into Lakehouse, into some other systems. And it's reasonable because RisingWave itself only has the row store. It doesn't really have the column store, right? You know that, well, I mean, if you really want to scan a lot of data, right, and do analytics, you really want to have a column store. And Snowflake, BigQuery, ClickHouse, whatever, right, or Redshift, they do have the column store. They are purposely built for analytics. So yeah, everyone is talking about, a lot of people are sending the data into these data warehouses, and we are thinking about, okay, look, it's actually not quite convenient to our customers, right? Because they actually have to maintain two different systems. They actually need to maintain RisingWave, and they also need to probably maintain a Lakehouse or some other systems, or purchase two different systems, right? They actually have to purchase Snowflake, and they probably have to purchase RisingWave. It's not quite convenient, and the cost-wise, it's also very expensive. So we started thinking about whether we should build our own storage engine. And actually there are two paths. The first one is to build from scratch and build a column store on our own. And the second one is to adopt existing technology, right? And we actually evaluated both paths. And we found that for building our own system, column store actually will take more than 6 months to get a first version. To get a first version, okay, it's not a production-ready version, it's to get a first version. And the shortcut is to implement ruckset style column storage. You probably, some of you probably don't really know what a ruckset is. It's a company that is acquired by OpenAI last year, and basically it uses the RuxDB to have implement the column store, which is a shortcut. And we found that when we implement that and find that the performance is really bad, and we could not go that way. And so we look at the other way, right? Well, whether we can adopt some existing technology. And that's why we started evaluating Iceberg. Yeah, this is our journey, right? So RisingWave can actually have the vectorized engine. But it doesn't really have the column store. So we actually have to evaluate column store. And we decided to pick existing technology like Iceberg. We are also trying the Delta, but basically Delta is like a Databricks thing, right? And Hoodie, yeah, if you know Hoodie, you know that, well, yeah, people can complain a lot about the ease of use, complain a lot of some configuration issues. So we actually have to go through go with something that is popular and reliable, and that's why we pick Iceberg. So that's the entire journey we have. The benefits of Iceberg is that in today's market, whenever everyone talk about Iceberg, they will think about, okay, no vendor lock-in, or probably cost efficient. But in our case, we actually treat Iceberg as the Postgres extension system, right? If you use Postgres, you know that you can actually plug any Postgres plugins into the extensions into a system, like timescale, like what is it called? Well, GIS, right? Well, GIS, right? Well, geospatial data processing thing, and some other tools, PG, IVM, right? Well, incremental view maintenance, and also these days, which one very popular one is the PG vector, right? So basically a vector database. We find that essentially you can consider Iceberg as the extension system to any of your existing database system, right? Let's say that you use MySQL and your MySQL doesn't really have any extension system. You can actually adopt Iceberg. So that's what with Iceberg, because Iceberg can have integration with all different kinds of query engines, you can essentially leverage all these kind of different query engines to query Iceberg data. Let's say that if today you want to run some parallel federative queries, right? You can just pick Trino. Or if you believe that you just want to save cost, and you just want to run your query on a single node, then just pick DuckDB. And if you believe that, okay, Snowflake is great, right? Well, it's because of the user, because we're so easy to use. Yeah, let's go with Snowflake. Or if you believe that, okay, look, well, I really want to do user-facing applications, then probably pick ClickHouse. Or if you want to do geospatial, then there's some other, my friend has a company called Wearables. Well, it's essentially Apache Synoda project, yeah. So yeah, that's a user, basically Iceberg became the extension system for RisingWave. And that's the entire, we started building an integration with Iceberg since 2023. And in 2024, everyone knows that Iceberg has won the so-called the data lake war, right? Because in 2024, Databricks acquired Iceberg, and Snowflake started contributing to the project started a new project called Polaris, which is essentially the Iceberg catalog, right? So I mentioned that in our case, we adopted Iceberg because we want to have a column store and because we want to have the extension system, right? But what about the other companies? Why they want to adopt Iceberg? So who should adopt Iceberg? Who should consider adopting Iceberg, right? I can tell you that, well, if you, let's say, if you do not really, no matter whether you're a startup or enterprise, right? If if your data set is like, okay, probably hundreds of gigabytes, probably you do not need to use Iceberg. Because Postgres is probably good enough, right? Or probably if you have a big memory, right, then probably you can store everything in DuckDB if you do not really care about fault tolerance, right? You do not need to use Iceberg. But as long as you have big data, right, or terabytes of data or even petabytes of data, Iceberg can actually save you a lot of money, right? I will cover that later. So essentially, there are two types of users who move to Iceberg. The first type is the Hive user, and the second user is the Snowflake user, or sometimes BigQuery users. So for Hive users, the user journey is like, okay, so they feel that Hive have some limitations, like they do not really have ACID support, and Hive doesn't really support the schema evolution, and Hive is terrible at partitioning, right? And Hive doesn't really support time travel queries. And because of all of these reasons, they started migrating from Hive to Iceberg. And it's essentially the reason why Iceberg got invented, right? Basically, Iceberg got invented because people are tired of maintaining Hive, and they want to build another standard so as to support all these kind of advanced features. That's why we have Iceberg, right? And there are another type of users. Well, that's definitely Hive users. And there's another type of user, which is Snowflake user. And Snowflake user moved to Iceberg because, well, okay, they think that's why Snowflake is too expensive. And they also concerned about the vendor lock-in, right? And they also want to have open data access and stream and batch processing. So I can explain this one by one. For too expensive, regarding too expensive, right? Why is costly? I mean, for every single database system, it has the computation and it also has the storage, right? For computation, Snowflake is definitely super expensive, right? If you store data in Iceberg, you can actually use some cheaper query engines like Trino or probably DuckDB to query the data, so as to get rid of Snowflake computation engine, right? And the other reason why it is too expensive is that, well, let's say that where you store petabytes of data, it is better to move to Iceberg. Why? Because for Snowflake, it doesn't really support you actually have to pay around $25 per terabyte per month to store data. But in Iceberg, you can actually leverage the object stores intelligence tiering, right? Where in S3, if you are in S3, you know that's where there's a feature called the intelligence tiering. Basically, can move your S3 data from standard tier to the Glacier tier, right? Which will cost only $12 instead of $23, which means that you can essentially cut the cost to half. Imagine that if you store 1 petabyte data, how much money you have to pay for storing this data. For every single month, you actually have to pay 23,000, right, US dollar for storing the data. But if you move to Iceberg, you can actually cut the bill to half. Right? That's why Iceberg can work. And definitely there are some other limitations like Snowflake doesn't really support the data replication across different time zones, not time zones. What's it called? AZ, right? Well, availability zone, right? Well, but Iceberg, you can always configure this S3, right? Regarding vendor lock-in, I mean, I probably don't really want to spend too much time on this, well, because it's quite straightforward, right? So because Snowflake is so expensive, and we have no idea about when they will increase the price, right? So yeah, moving to Iceberg can avoid the vendor lock-in. And about data access, right? Consider that if you have if you want to have, let's say, if you want to access your data using, let's say, pandas, like polars, like some Python libraries or some your own libraries, right? It's really difficult to store read the data from Snowflake, but you can directly read from Iceberg because, well, it's just a Parquet. It's just a bunch of Parquet files, and most of the systems have an integration with Parquet files. Okay, that's the open data access. And for streaming and batch processing, it's because, well, I mean, Snowflake, I mean, think about, well, how Snowflake does streaming, right? Well, I mean, what is called, well, Snowpipe, right? Snowpipe streaming, but it's too expensive. It actually will charge you based on the number of bytes transferred, right? Which can be super expensive if you have high velocity data. But if you move to Iceberg, you can use some engines like RisingWave to process the data, and we only charge you based on the number of CPUs, right? Which can save you a huge amount of money. So yeah, I have mentioned so many advantages of Iceberg. Then people will say, okay, let's just build Iceberg powered Lakehouse, right? It should look very simple, right? We can just ingest the data from Kafka, or probably using some tools like Spark, right? Or probably using some tools like RisingWave, and then store them into Iceberg, and then query from the using some query engines, right? No matter whether it's Pandas, Polars, Spark, DuckDB, whatever, right? There are so many query engines, but if you started implementing this architecture, you will immediately find that there are some limitations. Why? The first limitation we are hit is that how to implement Iceberg, right? Iceberg is just a standard. It's just an abstraction layer. If you really want to implement Iceberg or deploy Iceberg, you actually have to deploy at least two services. One is the catalog service, and the other one is compaction service. And today, most of the time, you actually have to pick your own catalog service and compaction services. If you are not familiar with these two services, no worries. I will cover these two parts. For the catalog service, well, you can just imagine that it's the brain of your basically a brain of your Lakehouse, right? So remember that Iceberg is a layer on top of Parquet, right? And you have a bunch of, let's say, 1,000 Parquet files or 10,000 Parquet files. You actually need to find a place to store all this physical information, like, okay, where my table is stored, right? And what the table's name, and what the column's name, and all these and probably what's the snapshot name, right? All this kind of like information, and all this information should be stored in catalog. Yeah, but if you look at today's catalog market, you will find that look. So many catalog services, right? Which one I should implement? Which one I should pick? Hadoop or Hive catalog, or so-called Hive catalog means that high meta store catalog, and or Glue catalog, or DynamoDB catalog, or JDBC catalog, or REST catalog, right? There are so many catalogs I should pick from, right? Which one I should go with, right? If you so here's my recommendation, okay? My personal recommendation. First of all, you probably do not really want to choose Hadoop catalog because it's not, yeah, it's just for local usage, and it's not for production, right? And then if you came from the Hive world, then I will not tell you that, okay, move away from Hive and just pick probably some Glue catalog or whatever, because there are a lot of nuances you have to handle. And for Iceberg, it actually works with your Hive meta store catalog, so that you do not need to migrate anything. So you probably can start from there and gradually move your data into the other catalog services I will mention later, okay? So if you come from Hive, yeah, you can just stay with HMS, Hive meta services. And if you are in AWS have pretty good services, right? It has Glue, right? Glue is a pretty good catalog, and in our case, well, I feel that most of the customers will use Glue catalog. because it's AWS native services, and it's very easy. It's good. It's good enough. Yeah, it's good enough. We didn't really see many DynamoDB catalog, and I don't really know who uses DynamoDB catalog in production, but DynamoDB catalog is also like a AWS service, right? AWS native service. So if you want to go with AWS native services, I would recommend you choosing the Glue catalog, right? And for JDBC catalog is it's not that popular, I have to say. Yeah, so skip this part. And then REST catalog. So look, if you do not really want to be locked in by AWS, and if you really want to have integration with all different services, right? Snowflake service, or probably Databricks service, or probably the BigQuery service, or Azure services, right? Then I would strongly recommend you to go with pick the REST catalog. Remember that REST catalog is just the abstraction, and it's nothing. It's not something like a detailed implementation. It's just the abstraction, and there are implementations, and the implementations include Snowflake-backed Polaris and the Lakekeeper, right? Well, these guys are here, and they have a talk, and there are some other projects called Graphino. There are some. We heard that's where they got deployed by some of the customers, but I have to say that so no matter what kind of catalog you want to use, you choose the REST catalog, right? Because it's the standard, and it's the future, and everyone is implementing the REST catalog. Even for AWS, they want to support the REST catalog in the future. So yeah. And then let's talk about the compaction. I don't really want to spend too much time on this because it's like very technical. But compaction is essentially, remember that Iceberg is a layer on top of Paquet, right? If you have 2-minute Paquet files, then scanning, let's say 1,000 or 10,000 Paquet files, then scanning these 10,000 Paquet files can take a lot of time, right? Because every single time you actually have to fetch the data. So a better way to support querying data, data querying is that you should compact small files into a bigger file. So that's why every single time instead of fetching 1,000 or 10,000 files, we can just fetch one single big file, right? That's way more efficient, right? And so compaction is big and it's important. So basically, in this figure, I showed that essentially it will pack all these different small files into a bigger file. So that's what, instead of scanning these 5 different files, we can just scan one single file. And today, the most popular compaction service we've seen is the EMR. And in AWS, it also have the what is called the Glue auto optimization, which is also pretty popular. For EMR, I mean, you can check the AWS documentation, and it's not easy. It's not difficult. It's not that difficult to set up, right? Well, I mean, definitely you have to set up. So for optimizing compaction, there are actually a lot of ways to optimize compaction. One thing you can, there are a lot of reasons you have to optimize compaction, right? I mentioned that, because there are small files. But essentially, we can actually optimize the compaction or the data layout based on the read patterns, right? For example, in this SQL query, we want to select all the logs where the timestamp is between these 2 days, right? How do we best query this get the best performance? Well, the way we can get the best performance is to resort the data based on the read patterns, right? So we can just resort the data based on the timestamp column, so that we can improve the predicate pushdown and the data skipping performance, right? So and that's to optimize the layout based on the read patterns, or do the compaction based on the read patterns. And the other reason we want to do compaction is because of the write, right? And the Iceberg by default was born not for streaming but for batch. If you check the original Iceberg repository, it will tell you that Iceberg is a table format for large, slow-moving tabular data, right? It's slow-moving tabular data, and it's not fast-moving tabular data, right? So it's not designed for streaming at all. So if you want to do streaming, then you will immediately find that these different files, right, will write a huge amount of small files, right? That's terrible. So essentially, how we can do that? I mean, look, well, all these different services, let's say that we have the data from Kafka, we have data from Kinesis, or we have the CDC from Postgres, MySQL, MongoDB, right? These files, well, you cannot just let this system to directly call the invoke a write action every time a new event comes in. You actually have to buffer the data in the cache, and then batch commit to the to S3 in order to reduce the number of small files. How do we do that? Remember that Kafka will not magically batch data. Kinesis will not magically batch data. CDC will not magically batch data. They are just a queue, right? And the thing you have to do is that you actually have to choose a system to do that, right? In Kafka, I mean, there's one native service called Kafka Connect, right? Where it can help you to dump the data, batch the data, and do the batch commit. But the problem here that's for Kafka Connect is not, it's basically a Confluent system, right? And I don't really think that the open source version supports the Iceberg. Correct me if I got it wrong. Yeah, but most of the people will choose some other open source systems like, Spark and Flink. So yeah, we do compete with Spark Streaming and Flink. We actually migrate for one company. We actually did a huge migration from 10,000 of Spark CPUs to RisingWave, and I have to tell you that Spark and Flink are pretty popular in doing in enabling the streaming ingestion, because they can do data batching, and they support exactly once commit. Correct me if I got it wrong, okay? And they also support the schema evolution. I'm not 100% sure about the Spark streaming, but for Flink, there is some ongoing work in doing schema evolution into Iceberg, but it's not ready yet. It's not ready yet. And using these tools, you can also do the pre-processing, right? Well, the so-called ETL, right? So, well, these tools are pretty good, but unfortunately, there are some limitations. One thing here, I know that's why I don't really have enough time, okay? But one thing here, okay, look, these tools are like, Java-based. So in many systems, in many companies, if they are, let's say, a Snowflake customer, if they are, let's say, a Redshift customer, they don't really want to introduce any Java library into their system, right? So they really want to use some other systems. And the other thing here I can actually not, Snowflake and, Spark Streaming and Flink can do, let's say, some data batching and some other things. But sometimes you actually have to write a Java code, right? Because the SQL is not like a standard SQL; it's their own SQL. But people really probably sometimes people just want to use a very standard SQL like Postgres SQL to write the data into Iceberg, right? And in many other cases, people really want to join multiple data streams and do the commit into Iceberg, right? There are all kinds of different use cases, and the requirement is pretty high. So in RisingWave, we actually did a huge amount of work over the last 2 years. We did a huge amount of work in improving enabling people to do a streaming ingestion into Iceberg. Remember that RisingWave was very good at doing streaming joins, doing the let's say time window functions, joins, aggregations, whatever. But specifically to Iceberg, we actually have already done a lot of works like exactly one semantics, exactly and like batch commit, right, and schema evolution, and we actually allow you to compact the data in directly inside of Iceberg. So, and more importantly, and many people really love that, is that we are Postgres compatible. So that's where you do not need to write any other Java language, Java code, and you do not need to learn any SQL other SQL dialect, right? You can just write Postgres. So yeah, I probably don't really. I'm running out of time, but I just want to mention that so RisingWave is building Rust, and in original Rust Iceberg interface, well, it was actually implemented Java, and the performance is really bad. So essentially, we started a new project called Ice Lake. That was started 2 years ago, and the project was invented just for building interface for Iceberg. And then later, we found that well, it's getting popular, very popular. And some guy in the Iceberg committee, if you know him, Brian Osland, say that, okay, hey guys, well, can you just, there are so many people who really want to use Rust implementation, right? Iceberg Rust implementation. Could you please, well, move this project to Iceberg committee? So that's why we donated the project to Iceberg, Apache Foundation, and now becomes the Iceberg Rust project. Today's RisingWave Iceberg project, right? Well, I don't really want to show any benchmarks, right? Well, people are also, okay, you are doing something like a benchmarking, right? I'm just here, I just want to try to compare RisingWave itself, right? For Iceberg Rust, well, using Iceberg Rust, we can actually achieve very similar performance doing scan, right? Scan the Iceberg data. RisingWave scan Iceberg data compared to Lakehouse scanning Iceberg data. We can actually achieve very similar performance. Remember that Lakehouse is fine-tuned for scanning. RisingWave doesn't really do a lot of huge amount of work in fine-tuning, but you can see that in this benchmark, the performance is very close. Yeah. So exciting thing in Iceberg committee, this is my last slide. And very exciting that we will have the Iceberg v3 probably next month. I hope that was next month. And it will support all kinds of the different data types like geometry, variant, and advanced features like binary dilation vectors, and also more importantly, we're supporting materials views, which allows you to do the so-called medallion architecture inside of Iceberg. And more than that, if you are enterprise users, well, you definitely really want to have the RBAC, right? Iceberg v3 will have that. Okay, that's all my talk. And if you really love to try Iceberg, yeah, just reach out to me. And or probably if you just want to talk about stream processing, also, welcome to talk to me. And yeah, thanks.